Hello students, welcome back to our JEE Prep channel. Hope all of you are doing well as usual. Today we will be studying velocity time graph. There are various types of velocity time graph. Now let's study one by one. The first velocity time graph is for the uniform motion. Now what do you mean by a uniform motion? When a body covers equal distance in equal time, I mean when body is moving with constant velocity, then we say that the body is performing uniform motion. Now here there are certain readings of the motion of the body at different times. You must have realized that at different times the velocity of the body covers 4 meters per second distance. That means the body covers equal distance in equal time, means the velocity of the body is constant. So then the graph of the velocity of this body is a line parallel to x-axis at v is equal to 4. So this is the graph of the velocity versus time when the velocity of the body is constant, means body is in uniform motion. Then what is the distance covered by the body when the velocity is 4 meters per second? That you have to find the area under this line. Now next let us see the velocity time graph for the uniform acceleration. Means what do you mean by acceleration? A rate of change of velocity with respect to time. Now let us study, there are two graphs for this uniform motion, that when the body starts from a rest position and the body starts from a certain position where the body actually has certain velocity. So we'll call that velocity as the initial velocity because we are treating that as the initial position. Now let's see when the body starts from its rest position. So if you see these readings, when t is equal to 0, velocity of the body is 0. That means body is at rest, and here body is starting from rest. Then after 1 second, the velocity attained by the body is 1 meter per second. After 2 seconds, velocity of the body is 2 meter per second. And after 3 seconds, velocity of the body is 3 meter per second. So if you plot this graph of velocity versus time, you get a straight line which passes through the origin. So here the acceleration of the body is constant. Therefore, the body is moving with constant acceleration, or this motion is known as the uniformly accelerated motion. Now this is one case. Now let us study the another case, that the body is already moving and after some time we consider the motion of that body. Okay, so then at start velocity of body is 3 meters per second. So after 1 second velocity of the body become 5 meters per second. Then after 2 seconds velocity of the body become 7 meters per second. And after 3 seconds velocity of the body become 9 meters per second. Then if you plot all the values of velocity with respect to time 0, 1, 2, 3 seconds, then you get a straight line which cuts y-axis. Then this velocity is known as the initial velocity. This velocity is known as the initial velocity. So this is u is equal to 3 meters per second, and then this becomes the final velocity, that is the 9 meters per second, because we are going to consider the motion of the body till 3 seconds. Then how to find the distance covered by the body? That we have to consider this trapezium OABD. Then area of this trapezium will give you the distance covered by the body in given time. So this is the trapezium. So area of trapezium OABD is equal to half into OA plus BD into distance OD. So this is half. OA comes to be initial velocity u and BD comes to be final velocity v, and this OD is time. So therefore this is the distance s is equal to half into average velocity into time. So this formula gives the distance covered by the body when that body is moving with certain acceleration, and where u is the initial velocity of the body and v is the final velocity of the body. Then what will be the acceleration? We know that this is a is equal to v minus u upon t. That is the first kinematical equation. From this first kinematical equation you can get the acceleration also. Now let us see a velocity time graph when the two bodies are moving with different velocities. So here we have two cases. This is the velocity time graph for a body A, and the other one is velocity time graph for body B. Now what we will do, we will compare the change in velocities of these two bodies, for the equal interval of time. So I have drawn perpendicular to time axis, and then I have drawn perpendicular to y axis. Now you must have seen that in the same time t, in 1 second, here the first body A cover this much velocity, attain this much velocity in 1 second, while the second body attain more velocity in 1 second. So the difference in velocity for this body A is less than the difference in velocity for the body B. So body B is moving faster than body A. Body B has more velocity than body A, means if here the B has greater slope, hence greater velocity, while A has less slope and therefore less velocity. I hope all of you understood this. The next is in uniform retarded motion. In uniform retarded motion, so when will the body have uniform retarded motion? When the body is already moving and the brakes are applied. Now let's study the uniform retarded motion. What do you mean by retarded motion? The motion in which the velocity of the body keeps on decreasing. This is also known as the negative acceleration. So when the body is under negative acceleration, then the velocity of the body decreases, and the graph for velocity versus time is this. So this is for retarded motion. Here the acceleration is negative. Acceleration of the body is negative. Now next is when the acceleration is decreasing. Now let us plot velocity time graph for the motion where acceleration is increasing or decreasing. Now, when the acceleration of the body is increasing, the velocity time graph will be this way. This is the nature of the velocity time graph when the acceleration of the body is increasing, and the nature of the graph when the acceleration is decreasing can be shown in this manner. So here, if you see students, initial stages the velocity is increasing fast, and later on the change in velocity gets reduced. But here initially velocity is large but the velocity reduces. This is the velocity time graph for the decreasing acceleration, and this is the velocity time graph for increasing acceleration. Now let us see when velocity time graph when the body is under gravity. What do you mean by body is under gravity? The body is either thrown in the upward direction or the body is released from certain height. So as usual, velocity is plotted along y-axis. Now time is plotted along x-axis in both cases, while velocity is plotted along y-axis in both cases. So in first we will study when a body is being thrown upward. Object is thrown upward. When object is thrown upward, that time the body is moving against gravity, hence the velocity of the body decreases, and when it reaches the highest point, velocity of the body becomes 0 and the body starts falling down, and when the body starts falling down, the velocity of the body increases. So for the upward motion, the velocity decreases, so the velocity decreases this way, and for the downward motion, here the body has reached at the highest point and then the body starts falling down, so velocity starts increasing. So always remember, when the body is thrown with certain velocity, say for example 5 meters per second, when the body reaches the ground, that time the velocity of the body is 5 meters per second only. So always remember, the initial velocity with which the body is thrown in the upward direction is the velocity with which body reaches the ground. But suppose if body is being released from certain height, when the body is released from certain height, the body is coming towards the earth's surface, the velocity increases. So the velocity increases, but after it reaches the ground, it bounces back and then it starts going against gravity, so velocity decreases. So this is the case when a body is released from height edge. So when body is released from height edge, the velocity of that body increases till it reaches the ground. After it reaches the ground, it bounces back and start performing upward motion. Then the velocity decreases. So these are the various velocity time graph for the motion. I hope all of you understood this velocity time graph.